Good Friday morning to you, students. Hope you guys are doing well today. Welcome to, yes, the next to last Friday that you seniors will have, but also actually the last Friday, because I doubt if you come in on graduation day. So, congratulations, the year's almost over, and also welcome to your last review sheet of the entire year. So, thank you guys for putting up with my raspy voice for the past 3 or 4 days, and wish I could change that, but I can't. So here we go. Um, you do owe me some homework from yesterday, and so I would like you to turn that in now at this time, please. Would you do that? Turn your homework in now at this time. Make sure your name is on it. Make sure you finish well. As a former coach, I am not known for my pep talks. That's probably one of the weakest areas of my coaching, but I will just simply say this to you guys. Excuse me. Please finish well. It's your last test. You know you need this. I guess if you did not pass the course because you did not pass the test, I guess you could retake the test. I just don't want that to happen to you. So let's finish well. Let's finish well. Let's get this thing taken care of the first time. Work hard in this review sheet. Remember, this review sheet is worth 5 bonus points. Okay? So you owe me homework. Please turn your homework in at this time. On Tuesday of next week, you'll have a test. I am planning on being there. No promises, but as far as I know, Lord willing, as long as nothing comes up, I will be there. Okay? Let's see. The review sheet is due Tuesday, the day you take the test. So make sure you have it totally done if you want the 5 bonus points. And without any further ado, go ahead and please pass your homework in now. I've waited about a minute for you to do that, so please pass your homework in. Let me grab a quick drink of water here. And let's take a look at this review sheet. You've had some review sheets that have been in the 30s, low 40s, high 30s. I'm ending on a pretty nice review sheet. So be thankful for that. And I am prepared. I'm not stalling. I'm just trying to make sure I get the right page number. All right, your review sheet, write this down please, is going to be page 577. At least that's the page that it starts on. You know it's going to go a lot further than that, but it starts on that page. I want you to do 11 through 59 odd. Now that's a total of 25 problems. Okay? So there's the review sheet. And let me tell you what we're going to do now. What we are going to do is we are going to work on this review sheet during this class period. So as I'm rambling, go ahead and get your books open to this page, please. We're going to finish it on Monday. I'm going to go ahead and tell you right now the name of the video, so write this down, okay? You're watching it right now, okay? But Mr. Harmon or some teacher is probably the one that loaded it up, so you don't know what they typed in necessarily. So if you want to watch this over the weekend or Monday night to help you get ready for your test, here's what you would type in. Berean Academy Geometry. Chapter 10. I have apologized so many times. I will continue to do so. I'm very sorry. I know it's very attractive as I cough into this microphone over and over. There's just nothing I can do except cancel class, and we're not going to do that. So, Berean Academy Geometry, Chapter 10 review sheet. There it is, okay? Piece of cake. So that's what you're going to want to type into your calculator, your computer at home on YouTube if you want to watch this later, okay? Copy all this down. And now for the rest of this video, I'm going to give you a help session with each problem, okay? And so I need you to really pay attention and take some good notes. And if you want to pause the video and just work on your own and then fast forward to the ones that you're struggling with, that's fine. No problem. Here we go. Okay, we're starting off with number 11. So if you do not know how to do that, you'll want to watch the square root of 2 times the square root of 22. I'm going to list off the perfect squares over here real quick. 2 times 2, 3 times 3, 4 times 4, times 5, 6 times 6, 7 times 7, 8 times 8, 13, 14 times 14, and then 15 times 15. Is that 225? I'm not sure about that one. I think that's right. So, copy these real quick. And here we go. All right, students, let's go ahead and multiply these two radicals together. I've taught you to multiply the outside number times the outside number. There are not any. And multiply the inside numbers times the inside numbers. Square root of 44. Okay? Now, if I asked you to tell me the answer to that, you would type into your calculator, and you would get 6.6. So there's one possible answer, 6.6. If I asked you to simplify this, then you would look over here at your perfect squares and say to yourself, do any of these numbers go into 44 evenly? Well, 4 does. 4 does. So instead of writing the square root of 44, I'm going to replace that with 4 times 11. Now, which one of these do I know? Do I know the square root of? Well, I know the square root of 4, so cross it off. Put a 2 on the outside, and now we have 2 square root of 11. Remember your last quiz, how I think almost everyone in the class did not take their radicals further? Well, don't assume that you're done. You have an 11 on the inside. Do any of these numbers go into 11 evenly? Well, the answer is no, so you know that you're finished, okay? This is called decimal form. This is called radical form. All right, number 13. This is interesting. This would be a good question on your test. 4 square root of 7 squared. That's number 13. Well, look, students, if you had 4 squared, that just means write the 4 how many times? Twice, and multiply, right? So, same thing here. I'm going to write this expression twice, so 4 square root of 7, 4 square root of 7. Why did I write the expression twice? Because I had a 2 right here. And I'm going to multiply. So outside number times outside number, that's 16. Inside number times inside number, that's 49. And hold it. That's a perfect square. Whenever you can take the square root of this whole number, that's called a perfect square. We know the square root of 49. It's just 7. So instead of having 16 times the square root of 49, I really have 16 times 7, because the square root of 49 is 7. Now if you multiply those together, you will get 112. 112. Let me get a quick drink of water, excuse me. And let's move on to number 15. Number 15. Square root of 5 times square root of 5. All right, well, that's not too bad. Square root of 5 times square root of 5. Well, 5 times 5 is 25, so square root of 25. And hold it, that's a perfect square. We know the square root of that whole number. The square root of 25 is just 5. Okay? That was pretty easy. All right, let's take a look at number 17. Number 17. All right, this one's going to be like number 13. So we have parentheses, 3, square root of 11, close your parentheses, squared. You ought to go ahead, you should get 99 for your answer. You ought to go ahead and just pause the video and try this on your own. That's up to you. I'm going to keep going, but you can do that. Okay, because I have a 2 right here, that means I'm going to write this whole thing here 2 times. So I'm going to write 3 square root of 11, 3 square root of 11. Then I'm going to multiply them. Outside times the outside is 9. Inside times the inside would be 121. Now hold it. This is a perfect square. I know the square root of 121. Definitely. So instead of having 9 times the square root of 121, I have 9 times 11, because the square root of 121 is 11. And then your final answer would be 99, which is what I said you should get. All right, that's number 17. Let's take a look at number 21. Number 21. Square root of 68. They want us to simplify this radical. Now, they didn't say solve it, they said simplify it. Now on the test, in case I ask you to solve this, If I asked you to solve this, you would type into your calculator square root of 68, and you would get out 8.25. Okay? I'm just saying in case you're asked to do that on the test. But they want you to simplify. Let's see if any of these numbers go into 68. I think 4 does. Let's see. 4 does for sure. So I'm going to use 4. I'm going to divide 4 into 68, and I get 17. So 4 times 17 is 68. Now I know the square root of 4, so cross it off, put a 2 on the outside. So 2 times the square root of 17, or 2 square root of 17. Now, remember on the test, you're going to have to make sure you've gone far enough. So now I'm left with a 17 on the inside. Well, do any of these numbers over here go into 17 evenly? The answer is no. So you know that you're finished. This is your answer. All right? Let's take a look at number 23. Number 23. All right, square root of 80. Now, if I asked you to solve that, of course, you would simply type it into your calculator. And you would get 8.94. But they're not asking you to solve it. I might on the test, but they're not on the review sheet. They want you to simplify. Now, here's your list of perfect squares, okay? Do any of these numbers go into 80 evenly? Now, to be honest with you, 16 does. But you might not have thought of 16. You might have saw the 4. So I'm going to go with the 4 first. Now, if you use 16, that's fine. You'll get the right answer, 16 times 5. But I'm going to use the 4, okay? So I'm going to go ahead and write. Let's see, 4 goes into 80 20 times. So 4 times 20, all right? Well, I know the square root of 4, so I cross it off, and I put a 2 on the outside. So now I have 2 square root of 20. But remember, you've always got to check and see if you can take that number further. Well, let's see. Do any of these numbers go into 20 evenly? Yeah, 4 does again. So now, instead of leaving it at 20, I'm going to write 4 times 5, which is the same thing as 20. Now, cross off your 4, take the square root of it, put a 2 on the outside. You multiply these numbers. So now you're left with 4 square root of 5. And that's your final answer, because none of these perfect squares will divide into 5 evenly. And by the way, remember way up here I told you could have used 16? Well, it would have been faster. 16 times 5 is the same thing as 80. Cross off your 16, and the square root of 16 is 4. And you get 4 square root of 5. Look at that. That's, whoa, sorry about that. That's the exact same answer I got down here, is it not? So let me grab a quick drink of water again, but there you go. Either way, you're simplifying. Just make sure you take your radical as far as it can go. All right, let's move on to number 25. Number 25. We are having a truckload of fun. Here we go. Number 25. All right, 507. 507. Now, on this one here, you're going to have to, hold on a second. You're going to have to use your calculator, okay? Because I'm telling you right now, I don't know how many of these numbers would go into 507. I know one does for sure, and it's pretty big. Let's see, 4 would not. 9 would not. Well, use your calculator, and if you were to start dividing these in, that's what you got to do. Just take 507 divided by 4, 507 divided by 9, 507 divided by 16, and go right down your list. When you get to 169, you're going to see that 169 goes into 507. In fact, here's what you would get. 169 times 3 is 507. Now, why would I want to use 169? It's one of your perfect squares. It is? Yeah, sure. 13 times 13 is 169. So, 507 can be broken down into 169 times 3. Now, cross off the 169, take the square root of it. That would be 13. And you're left over with 13 square root of 3. Now, if I asked you to solve that, which I'm probably going to have some of those on the test, you would type in the square root of 507, and you would get 22.52. So it all depends on what the instructions are, either solving or simplifying. All right, let's take a look at number 27. 27. Okay, this is pretty random. We've not really had one like this before, but it's good for you. We have a rectangle like this. That's number 27. And let's see. We have 4 square root of 6 and 3 square root of 3. And they want us to find the area and round to the nearest tenth. Now remember back in the old days, if you had a rectangle like this, and this was 4 and this was 2, how do you find the area? You multiply your length times your width, and 2 times 4 is 8, and that's your area. I hope you remember those old days. Well, same thing here. We're going to find the area of this rectangle, and the only way to find the area is length times width. So we're going to take length, 4 square root of 6, times 3 square root of 3. Well, let's see what we get. Outside number times outside number, that's 12. Inside number times inside number is 18. And now stop. You might want to say, oh, Mr. Earhart, I know what to do next. I'm going to take my perfect squares and use them. Well, hold it. Yes, I want you to usually, but look at the directions. You got to read the directions. The instructions, the instructions say round your answer to the nearest tenth. So they want you to type this into your calculator. So you would type into your calculator 12 times the square root of 18. And here's what you can take the square root of 18 first, and then whatever you get out, multiply it times 12. Either way is the same thing. 12 times the square root of 18 is 50.911. So we're going to round to the nearest tenth. That's 1 decimal place. So 50.9. All right, so there's the area of that rectangle. Very good. Number 29. Okay, we have a special triangle, 45, 45, 90. We love our special triangles. And so here we go. 45 degrees here, 45 degrees here, 90 here, and a little bit of water, excuse me. All right, here we go. What do the directions say? We have an X here, a 15 here. Find the length of the hypotenuse, write your answer in radical form. Okay, now look guys, I'm going to go over this and over this until I put you to sleep. I'm probably already been successful. In a 45, 40, 45, 90 triangle, your legs equal each other. Your hypotenuse equals the leg times the square root of 2, and the leg equals the hypotenuse divided by the square root of 2. Now they want us to find the hypotenuse. There it is, x. All right. They want us to write it in radical form. Now, how do you find the hypotenuse? Well, students, not being mean to you, but it's right here in front of you. Okay. I'll pull it down here. Nice sound effects. All right. The hypotenuse equals leg. Well, here's your leg right here, 15. 15 square root of 2. Now, some of you are like, oh, I know what to do next. I'm going to type it into my calculator. Well, you could do that, but again, look at the directions. The directions say write your answer in radical form. So you're done. I guess you could say x equals, since the hypotenuse is x. I really don't care. I wouldn't take off either way. But there's your hypotenuse. Radical form. We're done. Moving on with tons of excitement. Number 31. Okay, we have again another 45, 45, 90 triangle. So there's your 90, there's your 45s, and what do we have? A square root of 7 here, and an x. Now again, they want us to find the hypotenuse, same direction. So I'm going to come back here, and I'm going to do this, and this, and this, and that. Now there's the 3 things that we know about a 45, 45, 90 triangle right there. All right? You've got to have those memorized for the test. I'm telling you, you need to know those. I might even have you write them out from memory on the test. That's fair. I mean, you have to know them anyways. I probably will do that actually. But anyways, moving on. Let's find the hypotenuse. Well, here's how you find the hypotenuse right here. Hypotenuse equals leg square root of 2. So hypotenuse equals, for leg, here's your leg right here, square root of 7. I'm going to put square root of 7 and then square root of 2. Now they're multiplying, they're side by side. So the answer would be the square root of 14. Okay? Now if you think of all your perfect squares, 2 times 2, 3 times 3, 4 times 4, none of those will go into 14. You cannot simplify the radical. So that's it. We're done. We're looking good. Little drink of water and we're moving on. All right, let's take a look at number 33. Number 33. All right, 33 says we have a 45, 45, 90 triangle, and I believe they want us to find one of the legs, I believe. So here's 45, and here's 45, and we have an x, and a 3 square root of 2. Now, I'm not going to list out all the 3 things that we know about a 45, 45, 90 triangle, but I will tell you this. The directions say find the length of the leg, write your answer in radical form, or as a decimal. So that's totally up to you. We'll do it both ways. Now, we're looking for the leg. That's what the directions say, find the leg. Well, in a 45, 45, 90 triangle, what is the formula for the leg? Do you remember? It's hypotenuse divided by square root of 2. So what does the leg equal? Well, it equals the hypotenuse right here up top. Well, here's your hypotenuse, 3 square root of 2 divided by square root of 2. Now, obviously, if you were to reduce this, what happens to your square roots of 2? Well, they cancel out, and you're left with 3. So there's the answer to your legs, 3. One leg is 3, and the other leg is 3, because in a 45, 45, 90 triangle, the legs always equal the legs. All right? Okay, moving on to number 35. Number 35. Number 35 says, find the value of each variable. Write your answers in radical form or as a decimal. So it's kind of up to you again. Your triangle looks like this. And I believe if you look carefully, you're going to see that you have a 30, 60, 90 triangle. So 30, 60, and then 90. This leg right here is 25. And this is y, and this is x. Now I'm going to write this down once, and that's it. In a 30, 60, 90 triangle, we know the hypotenuse is twice as big as the shorter leg. We know the longer leg equals the shorter leg times the square root of 3. And we know the shorter leg equals the longer leg divided by the square root of 3. There we go. So with that in mind, let's roll. Here we go. Now the first thing you better do is label your sides. Which one's your hypotenuse? Which one's your shorter leg? Which one's your longer leg? Well, here's 30. Okay, that's the smallest angle. So 30 right here. Go straight across to the opposite side. That's going to be your shorter leg. Well, this is the right angle. Go straight across. This is going to be your hypotenuse. So the other side left has to be your longer leg. Easy enough. So what have I given you? Look at the problem. I've given you the length of the shorter leg. Well, if I know the shorter leg, isn't the hypotenuse, look at this, isn't the hypotenuse always twice as big as the shorter leg? So if the shorter leg's 25, then my hypotenuse has to be 50. So right now I know x equals 50. Booyah. Pretty easy. Now, I've got to find the longer leg. Do you see that? I've got to find the longer leg. So, there we go. There's my formula for longer leg. Longer leg equals shorter leg. What is it, shorter leg? 25. So 25 square root of 3. Now, if you chose to write your answer in a decimal, that would be totally acceptable. You would take 25 times the square root of 3, and you would get 43.3. Either way is fine. The directions said you could write your answer in radical form or in decimal form. All right? But if you write it in radical form, you better simplify it using your perfect squares. You got to simplify it, okay? Okay, we are moving on, taking a look at number 37. Number 37. All right, special triangle looks like this. And I know it's not a right triangle. We're going to go ahead and call it one, so I don't feel like redrawing that. So 30, 60, 90. We have a 94 square root of 3 right here. Pretty big side, 94 square root of 3. And I think we're calling the left side x and the right side y. Now, I mean, I don't mind putting this up here again. It's not a big deal. Here we go. Yes, sirree. I have no idea what I'm doing. You can't tell, can you? All right. So here's the things that we know about 30, 60, 90 triangles. Now, we better label our sides. See the 60 right here? That's your bigger angle between the 30 and the 60. And we know the 90 always gives us the hypotenuse. We know this is the hypotenuse right here. That's obvious. Out of the 60 and the 30, 60 is bigger, so go straight across. This is your longer leg. Here's 30, go straight across. This is your shorter leg. So I've given to you the longer leg. Do you see that? So from that, you're going to have to find the shorter leg and the hypotenuse. Now, I wouldn't try to find the hypotenuse first. That's kind of based. Hypotenuse is based on the shorter leg. I don't know what the shorter leg is, but look at this. See this formula here? The shorter leg equals the longer leg divided by the square root of 3. So shorter leg equals longer leg. That's 94 square root of 3 divided by square root of 3. So those cancel out, and now we know the shorter leg is very simply 9. So there we go. X equals 9. Now we've got to find the hypotenuse. Well, look at this statement. The hypotenuse is always twice the shorter leg. The shorter leg is 9, so the hypotenuse has to be 18, twice as big. So y equals 18. Moving on. Not too bad. All right, number 39. Okay, let's see what we got here. Number 39, number 39. Okay, this will be good right here. This will be challenging. Okay, there's our triangle. We have 30, 15, and 34. And this is labeled triangle A, B, C, ABC. And here we go. Let's have some fun. The directions say find tangent of A and tangent of B as fractions and as decimals. So we'll do both, all right? Are you ready for some fun? Let's find, first of all, the tangent of A. Are you ready? The tangent of A equals, well, here's A. Here's A. So go straight across. This will be my opposite side. This is your right angle, so this is your hypotenuse. So this is your adjacent side. Now, what is tangent? Remember SOHCAHTOA? SOHCAHTOA. Tangent is opposite over adjacent. So tangent of A equals opposite over adjacent. So the tangent of A equals opposite, which is 15, over adjacent, which is 30. So your final answer would be 1/2 when you reduce this. So the tangent of A is 1/2. Or you can do a decimal answer. Type in 1 divided by 2 into your calculator. You'll get 0.5. All right? So, not too bad. Now they've asked us to also find the tangent of B. So, tangent of B. Now here's angle B. Go straight across. And this is now going to become your opposite side. Hypotenuse stays hypotenuse. So this must be your adjacent side. So now they want us to find the tangent of B. Tangent of B equals opposite over hypotenuse. So the tangent of B would be 30, which is your opposite. I hope I said opposite over adjacent for tangent. That's what it's supposed to be. Opposite is 30 and adjacent is 15. And 30 over 15 reduces to 2. So tangent of B equals 2. Tangent of B equals 2. All right, moving on to number 41. Number 41, what other torturous things do they have for us to do? Let's see, we got a triangle that looks something like that. Not the best drawing, but good enough. We've got an 8 here, a 12 here, and a 4 square root of 3 there. Oh, 4 square root of 13. Sorry about that. 4 square root of 13. And we have triangle A, B, and C. A, B, and C. All right. They want us to find the tangent of A. So here's A. We're basing everything on A. Go straight across. This is your opposite side. This is obviously your hypotenuse. And this is obviously your adjacent side, the only leftover side. Now we're going to find the tangent of A. Well, the tangent of A is opposite over adjacent, so opposite is 12 and adjacent is 8. If you reduce that correctly, 4 goes into both of those numbers, you will get 3 over 2. 3 over 2. Or if you want to do the decimal form, you could say the tangent of angle A equals 1.5. 3 divided by 2 is 1.5. Now they've also asked us in the directions to find the tangent of B. So I'm going to cross off these two words. Okay, let's go to B. Here's B. It's your main angle. Okay, and we go straight across. This is now your opposite side. This is still your hypotenuse because it's still right across from the 90 degrees. And then the other side here, 12, will be your adjacent side. Now here we go. Tangent of B. Tangent of B equals opposite over adjacent. Opposite 8 over adjacent 12. And so if you reduce that correctly, the tangent of angle B equals, let's see, 4 goes into that. It'd be 2/3. Or if you want a decimal form, you could say the tangent of B equals 0.66, and it keeps repeating, 0.6666 repeating. All right, so there's your two answers, depending on which one you want to go with. And let's take a look now at number 43. Number 43. Oh, these are calculator problems. Can I get a yeehaw? All right. Tangent of 81 degrees. Well, you better not be using that -1 button. We're not looking for an angle. It's just tangent of 81. Make sure you're in degrees. And I think someone's messed with mine again. Nope, we're good. All right, tangent of 81 degrees. So tangent 81 degrees. 6.3138. 6.3138. Not too bad if you ask me. Pretty simple. All right, number 45. You guys would love a test full of these, I'm sure. All right, tangent of 24. Tangent of 24. Excuse me for yawning. Tangent of 24 is 0.4452. 0.4452. Quick drink of water. Moving on to number 47. All right, number 47. Let's get a new page up here. I think that'd be wise to do. Let's take a look at number 47. Looks like this. All right, there we go. That's number 47. Now, find the cosine of A, find the sine of A and the cosine of A as fractions and as decimals. Round your answers to 4 decimal places if necessary. So, find the sine of A. Let's write that down. They want us to find the sine of A and the cosine of A. Now, we're dealing with angle A. So here's angle A. Go straight across. Here's A. Go straight across. That's going to be your opposite side. And then here's my right angle. So 9 is going to become your hypotenuse. And then this side right here would be your adjacent side. Now, how do you find the sine of A? SOHCAHTOA would be opposite over hypotenuse. Opposite 5 over hypotenuse 9. So you're more than welcome to write 5/9, or you can type that in and you would get 0.5555 repeating. Either one of those two answers are acceptable, 5/9 or 0.5555 repeating. All right, how do you find the cosine of A? Now the cosine of A, SOHCAHTOA, is adjacent over hypotenuse. So adjacent is going to be 2. Very sorry for yawning. It is well past midnight, guys, as I'm making this video, so a little tired. Okay, cosine of A, adjacent, which is 2 square root of 14, over hypotenuse, which is 9. So you're more than welcome to leave it like that. Now, if you want to try to type that into your calculator, I'll try to help you. You would take 2 times the square root of 14 and hit enter. You should get 7.4833, and then divided by 9, enter 0.8315. 0.8315. All right, and that would be the answer to 47. So moving on to 49, making some really good time here, class. Really good time. Okay, okay, let's see what they got for us for number 49 here. Oh, calculator problems again. Can I hear a woohoo? Love it. All right, sine of 57. Sorry about that. So attractive. Sine of 57. Break out the handy dandy calculator. You should get 0.8387 if you round correctly. All right, moving on to number 51. Excuse me, here we go. Let me grab a quick drink of water. Sorry, students. Okay, wow. It has been a rough week. All right, number 51. Cosine of 31. Cosine of 31 degrees. And, that button is sticking on the calculator. That would probably be because my younger son poured Kool-Aid on the calculator yesterday. All right, well, see if I can get this thing to work. Cosine, the wonder, the awesomeness of having kids. Cosine of 31. Okay, 0.8572. And he also assured me he had cleaned it well. I can tell that he did. 0.8572. That's 50, 49, and 51. Calculator problems, okay? All right, I hope you're hanging in there. Hope you're with me. You better be learning. Don't just do this to get it done. Let's learn. All right, it looks like they give us a triangle in 53. I'm assuming we're going to need it. Maybe I should have read first, but I didn't. Typical male, read the instructions last. There's my triangle. We got a 10, an X, and a Y, and a 31 degrees. All right. Find the lengths of the legs. Round your answers to the nearest tenth. That means 1 decimal place. So here we go. Oh, man. Okay. Do we have a special triangle? 30, 60, 90? No. 45, 45, 90? No. Can we use Pythagorean's theorem? No. Because we only know one side. We don't know two sides. So no. So the only thing, well, no, that's not what I'm looking for. The only thing we can do is use our trig functions. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Now, they only give us one angle right here. Excuse me, please. And that one angle is 31 degrees. So, based on that angle right there, go straight across, and this would be your opposite side. Here's your right angle, go straight across. This would be your hip cool side, and this would be your adjacent side. Now, they want us to find x and y. Do you see that? Guys, I just can't quit coughing, so I apologize. We'll just have to work our way through this. So sorry, it's very embarrassing. Okay, do you see how we don't know the adjacent or the opposite sides? So don't use tangent. Please don't use tangent. The known side is hypotenuse, so you want to use either sine or cosine. It doesn't matter. If you were there, if I was there, I would let you pick. I'm going to use sine. So sine of what angle? What's my special chosen angle? 31 degrees equals, and what does sine equal? Opposite over hypotenuse. So opposite x over hypotenuse 10. Now we should know how to solve this. We're not looking for the angle, so we're not going to use our sine to the -1 button, our inverse sine button. The bottom of the fraction is 10. I'm going to multiply both sides by 10. Multiply the right side by 10, and you're left with x. Multiply the left side by 10, and you're left with 10 times the sine of 31. Now, the sine of 31, according to my Kool-Aid covered calculator, is 0.5150. So 10 times 0.5150 is 5.15. So there, we found x. Cool. Very cool. 5.15. I need to get a drink of water, excuse me. Okay. Now, students, you're welcome to use trig functions again to solve for y. But why do that? Use Pythagorean's theorem. Don't you know two sides? You know one side of the right triangle is 10. You know that another side of the right triangle is 5.15. Use Pythagorean's theorem. It's so fast. L squared plus L squared. Learn to use your shortcuts. Equals 8 squared. Now one leg we don't know. We're going to call it y squared. The other leg is 5.15 squared, and the hypotenuse is 10, so 10 squared. So now we have y squared plus 5.15 squared is 26 point, I'm going to round it, 26.52 equals, and 10 squared is 100. Now we're going to subtract 26.52 from both sides. And when we do that, we're left with 73, I'm going to round it, 73.48. Now we're going to take the square root of that. At least we were going to. And I've made a mistake here. Hold on one second. Sorry about that. You should get 8.57. I'm going to put 8.6. So y equals 8.6. So there. We did it. The direction says solve for x and solve for y. Find the two missing sides. Now, I don't think the steps are that hard. I think it's hard for you scholars to know when to do what. So let me run some thoughts by you again, okay? First of all, always check and see if you've got one of your special triangles, 30, 60, 90 or 45, 45, 90. Next, check to see if you can use the one and only Pythagorean theorem. And then, after that, then go ahead and use your trig functions, okay? Or your trig ratios, whatever you would like to call them. All right, number 55. Calculator problems. Can I get a woohoo? All right. So, this is a little bit different now. Tangent of A equals 3.2145. Look at this. They want us to find an angle. And they're giving you this over here on the right side. Remember what to do, class? Hold on one second here. You would type tangent, -1 or inverse tangent. And on my calculator, a parenthesis pops up automatically. And I type in 3.2145. and then hit enter, and you should get 72.7 or 73 degrees. Now in these directions they said round to the nearest tenth, so 72.7. Let's take a look at number 57. Number 57. Tangent of A equals 1.2067. So let's see what we get. You're looking for the angle, so tangent inverse, up pops the parentheses, type in 1.2067 and then hit enter, and you should get 50.4 degrees. 50.4. Alright? Now, according to my notes, the only problem left is 59. If I don't feel like that's hard enough for you, we're definitely going to try another one, but I think that's good enough. It looks like it's pretty good. So I want to make sure we get some practice here. Okay, there's a right angle. That's a Q. You can look in your book and see all of this if you need to. PQR, triangle PQR. And they want us to solve the triangles. Now, what are the steps I gave you? I'm not going to leave them up. I'll go to a new page. I told you step 1, I'm going to use shorthand. Check for special triangles. 30, 60, 90, 45, 45, 90. Step 2, solve for the sides first. And what do we love to use if we can? Always try to use Pythagorean's theorem. Always try to use Pythagorean's theorem if you can. And then step 3 was solve for the smallest angle first, and then find the other angles. Now, if you wrote all this down, that's fine, but you've got it in yesterday's notes. We just covered this yesterday. And then find the other angles. So, other angles. All right. Now, let's go back a page. Here we go. Step 1 says, see if we have a special triangle. Well, I have no idea. I don't know what this angle here is. I don't know what this angle here is. So as far as I know, we don't have a special triangle. 30, 60, 90, or 45, 45, 90. Step 2 says, find the sides first and use Pythagorean's theorem if you can. Well, we can use Pythagorean's theorem. We know two sides. We know a leg and a leg. We don't know the hypotenuse. So here we go. Leg squared plus leg squared equals hypotenuse squared. In this case, it's a Q. So we have 14 squared plus, let me clear off my screen, 14 squared plus 23 squared. And that would be 725. So 725 equals Q squared. Now, we're going to take the square root of 725, and we get 26.9. Glance at the answer sheet here, see if that's right. Number 59, yes. 26.9 equals Q. So I'm going to come up here, and I'm going to write 26.9. Okay, now, if you'll look at your steps in your notes from yesterday, or look at the screen here, you solve for the sides first, use Pythagorean's theorem, find, now look, solve for the smallest angle first, and then find the other angle. So, how do you know what the smallest angle is? Well, remember, you find the smallest side. What's the smallest side out of my three sides? 14 is. If that's your smallest side, go straight across to the angle opposite that side, and that angle is your smallest angle. So we know we're going to solve for angle R first. Now, if we're going to solve for angle R first, then this is going to be called my what side? Opposite. This is going to still be called my hypotenuse, and this is going to be called my adjacent side. And now, I'm telling you guys, you know all three sides. I don't care if you use sine, cosine, or tangent. It just doesn't matter. So I'm going to go ahead and use sine because I feel like it. Sine of what angle? What's the angle we're dealing with? R. So sine of R equals, and what is R? Or what is sine? Sine is opposite over hypotenuse. So opposite over hypotenuse. There we go. Well, look, we're looking for the angle. We're trying to find R, right? And so we know all the numbers over here. So we're going to type into our calculators sine -1, up pops your parentheses, and you would type in 14 divided by 26.9, close the parentheses. So let's see what happens here. I'm getting 31.4 degrees. 31.4. Now, that obviously is R, angle R. So I'm going to come up here and I'm going to write 31.4. Now, you know, on the test, I'm going to let you use whole numbers there. So 31 degrees, 31. Now, we know all three sides of the triangle, and we almost know all three angles. We're just missing one angle right here. Well, we know we can take 90 plus 31. 90 plus 31 is 121, and then subtract that from 180. And you will get 59 degrees. So angle P is 59 degrees. And just like that, we're finished. Your test will have a bunch of problems very similar to this review sheet. I hope that you'll study, work very hard, and be ready for your test on Tuesday. Okay? You do not have to finish this, although giving you 2 full class periods, I have no I would have no understanding as to why you would not finish this review sheet. Doesn't make any sense to me when you have 2 class periods to do it, and I hope that you will. I've enjoyed teaching you guys this semester. I will see you on Tuesday for your test.